Hello everyone, my name is Datsai. I am a student of ECC section. My roll number is 20BQ1A04G8. Now I would like to give seminar about nanomaterials.
Nanomaterials. Introduction of the nanomaterials. This is the branch of chemistry mainly deals with the size of particles like atoms, ions, molecules, or compounds ranges from 1 mm to 100 nm are particularly known as nanomaterials. 1 nm to 100 nanometers. What happens? The particle size has been changed. The same particle, when its size has been changed, it will bring the same significant changes in their properties, particularly in optical properties, mechanical properties, physical properties, chemical properties, including catalyst activity, electrical properties, and magnetic properties, etc. Because of these features, these materials are having some fundamental importance over the other materials. Hence, they are well known as materials of known and future. Classification of nanomaterials. Nanomaterials are classified into three types: carbon nanomaterial, inorganic nanomaterial, biological nanomaterial. Organic and classification. Types of carbon nanomaterials are crystal carbon consists of graphite and diamonds. In graphite, graphene. In graphene, there is a fullerene carbon nanotube, and in that one there will be arm chain and zigzag and chiral. And diamond, there is no specifications, including in diamond. Fullerene was discovered in the year 1985 by Robert Kruger, H.W. Kroto, and R.S. Valley. Fullerenes. Spherical graphene is known as fullerenes. Diameter of a C60 fullerene is just 0.7 nm. Hence, it was treated as a zero-dimensional material. Fullerenes are classified into two types: even number fullerenes or high number fullerenes, and odd number fullerenes and or lower membered fullerenes. These are when we go through even number fullerenes, these are the fullerenes made with hexagons only. Example like C60, C72, C78, C120, C22, C240, C540, C1080, etc. When we go through odd number fullerenes, these are the fullerenes made with both hexagons and pentagons, like C37, C41, C57, C61, C77, etc. And this is the structure of fullerenes, and this is known as graphene, 2D graphite, and these wrapped up into even numbers like this C60 fullerene, and this is the diagram of C60 fullerene wrap into odd number, and this is the diagram of odd number fullerene. Carbon nanotubes. Carbon nanotubes was discovered by Suminyo Lijima in 1991. Carbon nanotubes. Cylindrical graphene is well known as a carbon nanotube. Carbon nanotubes are also classified as a creation of a single wall carbon nanotubes. Arm chain single wall carbon nanotubes. In graphene has been chosen an imaginary rolling axis line joining the chair conformations of hexagons. Then it may be yield arm chains single wall carbon nanotubes. Or if graphene has been chosen an imaginary axis passing through most number of carbon atoms, it may also yield arm chain or symmetrical single wall carbon nanotubes. Zigzag single wall carbon nanotubes. In graphene has been chosen an imaginary axis line joining the zigzag carbon atoms. It may always yield zigzag type of single wall carbon nanotubes. Or if graphene has been chosen an imaginary axis passing through minimum number of carbon atoms, it may always give a zigzag single wall carbon nanotubes. Chiral or asymmetrical single wall carbon nanotubes. In graphene has been chosen an imaginary axis passing through at least number of carbon atoms, or it may be at least one carbon atom. It may gives asymmetrical single wall carbon nanotubes. Fabrication or preparation or synthesis of carbon nanomaterials. The following methods are used to synthesize various types of carbon nanomaterials. They are carbon arc method, used to produce fullerenes; laser ablation method, assiduously exclusively used to produce single-wall carbon nanotubes. Chemical vapor dispersion method (CVD) used to produce a mixture of carbon nanomaterials. Let us see about a carbon arc method. Consider a quartz tube. Two graphite electrodes with different surface area has been placed in quartz tube with 1 mm distance apart. These graphite electrodes are connected with a DC battery producing 50 to 120 ampere current. The quartz tube is completely evacuated with helium gas. Through the power source, current is allowed to pass through these two graphite electrodes and arc is produced. This arc may vaporize one of the graphite electrode which is having a leisure surface area. The vaporized graphite may decompose into carbon soot particles may recognize in a helium gas environment and gets settled down as rock-shaped deposit over the other graphite. The soot deposit is finally collected and examined through a transmission electron microscopy (TEM). We may found exclusively fluorescence. Next one is a laser ablation method. Consider a quartz tube placed in a furnace which can produce 1200 degrees Celsius. One end of the quartz tube is placed with a Nd:YAG laser and the other end with water circulated copper cup. The center of the quartz tube is placed with the graphite rod, which is the source of carbon atom. The quartz tube is completely evacuated with the argon gas. The graphite rod is activated at 1200 degrees Celsius and gets bombarded with the Nd:YAG laser beam. The carbon atom expelled from the graphite surface recognized in argon gas environment as a single-wall carbon nanotube. Tubes and gets settled down in water circulated copper cup as soot. The soot deposited is examined with the TEM and found exclusively single-wall carbon nanotube.